Hey there, YouTubers! Whew. That's good stuff. Oh my... Oh! Oh, it's so loud! Oh! Why? Why, son? Why you gotta do me like this? Oh! Oh my gosh! Welcome back to Blackness. Now you can't see me because there is a lack of light. But before some witchcraft, wah! You can slowly see me get brighter and brighter. However, how loud is this light? To answer that, today we're going to explore light as a part of my energy series, part 3. Now we've talked about light many times before, mainly how it's created. Today we're going to explore light on a quantum scale. We're first going to talk about what light is, briefly how it is created, and then finally the seven types. And then how light carries energy. Light exists as a wave. These waves are oscillating in electric and magnetic fields. This can be represented as an electric field wave running perpendicular to a magnetic field wave, as you can see here. Electromagnetic radiation is a quantum field that fills space, and light exists when there is a disturbance in the field. Now, as I've mentioned before in other videos on my channel, the disturbances are caused from moving electric charges in nature. These disturbances move as a wave in the field with electric and magnetic components. But when zoomed in on more closely, the wave in the field resolves into individual particles called photons. Now, because light is a form of energy, it exists on a spectrum called the electromagnetic spectrum, which is related to the amount of energy that light is carrying. Okay, with that out of the way, now I can talk about how light or electromagnetic waves are generated. Let's look at the atom. At its center you have the nucleus, and around it you have electrons. I say around because I've mentioned this in my previous videos on energy. Electrons usually are in ground state. This is their lowest energy level. When a specific amount of energy is added to some electrons, they're bumped up to a higher energy level. This state is very unstable, and the electrons want to return to ground state. So to conserve energy, a photon of light is released, and depending on the amount of energy added before, this will determine the wavelength of light. This wavelength can be put on a spectrum. Contacting YouTube, this is Dr. Sheep. Yeah, I want monetization. Jeez, that was mean. As stated before, the electromagnetic spectrum is split into 7 different sections of wavelengths. The longest of these waves are radio waves. Radio waves are classified by having a wavelength greater than 10 millimeters or 1 centimeter. The Earth's atmosphere is relatively transparent to these wavelengths, making them great for low information wireless transmission. These waves are also so low in energy and frequency that they don't interact with the human body, thus there's no negative side effects. Take my truck's radio for example. It detects radio waves, reads the information in those waves, and then turns that into sounds that we can hear. I came in from the wrong direction, but that's okay. The next section of the electromagnetic spectrum are microwaves. They have wavelengths from 10 millimeters to 100 micrometers. The longer wavelengths of these sections are often called millimeter waves because they have wavelengths from 1 to 10 millimeters. These are the waves used for 5G cellular data connectivity. We're all familiar with what happens when you put a jagged piece of metal in a microwave. It sparks. Microwave ovens use microwaves to cook food. Duh. Now, they don't use 5G wavelengths, but it makes you wonder, could 5G interact with the cells in your body and give you cancer? I'm not a fan of fake news, so I'm not going to say if 5G is bad or not. However, I will say the Earth's atmosphere is not very transparent to millimeter waves, meaning that lots of cell towers are necessary for 5G to function. Why can't I change the channel? Oh, you know what? It's a QLED. My pixels must have burned in. That's unfortunate. Have you ever lit a fire outside when it's cold? If you have, then you know what happens, and that you feel warmer. This warmth comes from the next section of the electromagnetic spectrum, infrared waves. These wavelengths are from 100 micrometers to 740 nanometers. Everything that we experience in our everyday life is emitting heat energy, and most of that energy falls in the infrared spectrum, which can be picked up by special cameras. They have many applications, from using to cook food, or if you use smaller wavelengths, you can control your TV. Here's a fun experiment for you can try at home. Grab your TV remote and a camera or a cell phone with a camera and point the end of the TV remote that you point the TV at the camera. Look through the viewfinder as you push one of the buttons, and you'll see the IR LED turning on as you push a button. I am super close. I hope you can see this. Reading Rainbow! Oh my gosh, I about took out my entire recording studio. Oops. The next section is one we're all familiar with. Visible light. Visible light has wavelengths from 740 nanometers to 380 nanometers. I've talked extensively about visible light. Unfortunately, I don't have any lenses or mirrors, so I can't cover that. I have covered color and how we humans perceive it. You can check out my video, What is Color, or my philosophy video, Does Color Matter? However, I will give some more basics today. Visible light is ordered from longest wavelength to shortest wavelength. This is called Roy G. Biv. Red is the longest and is followed by orange, yellow, green, blue, indigo, and violet. You can see this for yourself if you have a triangular glass prism, a flashlight in a box with a slit pointing at the prism, and you'll see the reading rainbow. Why, hello there. I have my fun fact book. I'm in my fun fact chair. That means it's time for a fun fact. Today's fun fact has to do with the origins of measuring the speed of light. In 1676, Olaus Romer used the moons of Jupiter to calculate the speed of light. He had calculated when an eclipse should happen, but noticed there was a delay. This delay was because of the speed of light. Thus, he calculated what c is. Isn't that just fascinating? Oh, gonna get a nosebleed if I keep doing that. The next section is ultraviolet. This section has wavelengths from 380 nanometers to 10 nanometers. The sun outputs UV rays all the time. However, our atmosphere protects us to an extent. These wavelengths are broken down even further into UVA, UVB, and UVC. UVA has the longest of these wavelengths, and you're most likely to experience them, and very rarely will you ever experience UVB. UVC is almost impossible to experience at the latitudes humans inhabit. UVC is just too short of a wavelength and just can't make it to the surface of the Earth. UV rays are known to cause cancer in humans and can kill living tissue. For this reason, you should always wear sunscreen when you're outside to protect your skin. UV rays are actually quite interesting in their applications. For one thing, we can use them to disinfect surfaces. UV rays could, in theory, be used instead of blue light in optical disc drives. However, to get enough of a performance increase, you need to use the really short UV wavelengths, which ionize air. The ionized air sticks to the parts of the disc player, which would ruin the disc player. For that reason, you won't be seeing UV discs anytime soon. Bonus fun fact, at 10 nanometers, you're approaching the size of modern transistors. And the most recent have actually gone sub 10 nanometers and are now at 7 nanometers. So I've combined the last two sections, X-rays and gamma rays, into the same section for a very specific reason, but I'll get to that in a minute. X-rays are split into two sections, soft and hard X-rays. Soft X-rays have wavelengths from 10 nanometers to 100 picometers. Hard X-rays occupy the same wavelengths as gamma rays, less than 100 picometers. However, they have a distinction. X-rays come from the acceleration of electrons, and gamma rays come from the atomic nuclei. X-rays, as you know, have uses in looking at broken bones. Gamma rays are used to destroy tumors. I've talked about gamma knives before in my day on death rays. Gamma knives and X-rays and gamma rays are all still very dangerous to humans, and you should not play with them, period. We've now gone through the entire electromagnetic spectrum. However, I've still yet to demonstrate how light carries energy. I have a few demonstrations left to show you though. We've all seen my laser before. We know what it can do. It pops balloons. Well, but why? Well, so much light hits the balloon in one spot that the molecules begin to vibrate. A lot. This is heat, and this breaks down the molecules in the balloon. This weakens the balloon and causes it to pop. Another example is the calcite orb. When blue light hits it, it's re-emitted as green light. Ooh, ooh. The photoelectric effect demonstrates that visible light can be turned into electricity. The same idea works for an antenna. When a radio wave of a specific frequency hits it, it generates a small electrical signal that is read by a computer and turned into sound. It's the same idea, it just doesn't generate enough usable electricity. Unlike the solar panel on, say, a calculator, which can generate enough usable electricity. Finally, for the moment you've all been waiting for, ow, I hurt my ankle. How loud is sunlight? Well, sound can be measured in watts per meter squared, same as light. Unfortunately for us normies, that doesn't really help us. But we can convert that decibels, which we know how each decibel affects you. To calculate decibels, you need to take 10 times the log of the ratio of the threshold of hearing. The threshold of hearing is the least audible sound humans can detect, which is represented by I subscript O, which is 10 to the minus 12 watts per meter squared. So, how much light does the sun put out in 1 square meter? Well, on the right spot on Earth, we can get upwards of 1,000 watts per meter squared. So let's do the math. That comes out to 140 decibels. For reference, a jet engine produces 140 decibels, and the pain threshold for humans is 125. I also wanted to find out how loud my laser is, or how the calcite orb, or how loud the calcite orb is. However, the instruments needed for this are like $1,000. So if enough of you subscribe, I can do that in the future. But in the meantime, I'd like to thank you all for watching. Please like, comment, share, and subscribe. New videos every other Friday, 2 p.m. Central Time, and good night. Subs for trees, subs for trees, subs for trees, subs for trees. Oh, you're still here? I thought I told you to go home. Oh, you want more? I'm flattered. Check out the playlist. If you want exclusive content, check out my Instagram, Dr_sheep_YouTube. That's all lowercase. If you want to help the earth, subscribe. When I reach 100 subscribers, I'm going to plant 10 trees. If you feel that's too small, then check out my channel where I lay out even bigger goals. Finally, stick around for the next 20 seconds to give me that sweet watch time. Bye!